many, many years on the computers. Berni never touched a computer, so when he was lauded for being such a big user, I had done all the computer work. So his getting the award gave me great, great satisfaction. It happened about 15 years after I had retired, but it also was a highlight of my career. I really felt very satisfied that the work I had done at the lab, at the lower pay that they managed to give me, was of some value. So this is a picture of us in the 1960s, and I'll be using it every so often because it just illustrates the importance of it. Also, when he was awarded the Medal of Science, the lab had him speak at one of their distinguished lectures series, and when we walked in, I went to the lab to see it because I thought, to me it was important. I had not really seen Berni since I worked for him, I think about 20 years before, and maybe even longer than that. And so when I walked into the auditorium at the lab, this picture was on the screen, and it kind of stunned me to see myself at 20, maybe 26, 27, I can't quite remember, but there. And the picture also became very prominent in 2015 when the lab decided that it was going to honor him for his 90th birthday with a symposium. And they invited me as a special guest to come to the symposium. And here we are, 60 years after I'd started from the lab. So it was kind of a fun day to be. It was an all-day symposium. There were many speakers there, which was really nice for me because I saw a lot of people I worked with. Working with Berni did not mean just working with Berni. People would come there during the summer, and professors at colleges and work with him on projects that had to do with molecular dynamics. Graduate students, actually, of the people here, Bill Hoover was a lab employee, and I did a lot of work with him. Charles Bennett was a Harvard student who elected to have Berni as his PhD advisor, even though Berni was not at Harvard. And he came to the lab for a summer, and I worked exclusively with him on his PhD work. And he is the only person that ever took my molecular dynamic code that we call STEP and actually took it back to Harvard and ran it for himself. He understood it and he knew what he wanted to do. And then several years later, after he'd gotten his PhD, he came to the lab to give a talk about the work that he had done. And it was really fun to see him after all those years, after a few years, and be able to talk to him. He told me that I was the only person that he chatted with who did not have to spend half the time explaining what the code was about before they started to tell the work he did. At the symposium also was Dan Frankel, who I had never met before, but I was rather fascinated because he came to me and said, I have wanted to meet you for the last 25 years or more because I've seen your name at the end of all these papers that people have worked. And he knew I had been a programmer, but that was the only place he ever saw my name. And he was fascinated that I had worked on computers at such an early stage. The other person I have starred here is David Snipperly. And he's really the last person that I worked with in conjunction with Berni, and I'll explain a little bit more about the work I have to remember to. These are the studies that I did on the computers with Berni and somebody else. I never read the papers, and I know you can't read. There's 18 of them, and all of them were studies in molecular dynamics that started from the very early stages of the Univac when I worked there, and progressed over the years, and different aspects of the molecular dynamics is a field of the study of how molecules move way down in the molecular atomic level. And we started with the simple things first, and then progressed and progressed, went through things like diffusion and thermal conductivity, words that really didn't have that much meaning to me because I'm not a physicist, but I knew I could interpret the formulas just fine. So and all of this ended up with the top paper there that we did with David separately, and that has been the physical review, whatever the journal is, keeps track of how many people cite the article when they have to write either a paper or a book, and they want to get the information from the article. And when I saw Dave at the symposium, he was so pleased to tell me that it was over 8,500 citations. Last week, I looked it up, and it has already gone to 13,100. So the paper is still one of the most used references to the work of molecular dynamics that Berni has been honored for doing. Each one of the articles, including the one with Dave, I am acknowledged in the paper. So then there's many papers out there that have my name shows up on the internet. When I look it up and dig real deep on the internet, I can find these references. One of the interesting things that I found was that Berni once told me that he had put me as an author of one of the papers, and what had happened was that a scientist had come from another university, Dr. Salzberg, and he and I had spent the summer together working on a program that he wanted to write up. And when he was going to come back and finish it the following year, but unfortunately he was in a car accident and died and never made it back. And since I had worked with him and Berni hadn't been involved with our talk together, what I was doing, at least he had an idea, but he didn't know any of the details. He had me write up a write-up of what I had done, and he gave it to him, and then he and Big Young had written up the paper Hard Sphere Equation of State, which happens to have my name also as an author, which I thought was very nice, but I didn't know any of this until I happened to run across it as I was digging through the internet just last month. And I got a copy of it, and it did remind me of what the work I had done. It rather pleased me. I don't know how many of you know that most of the molecules we studied, we just made them as round balls that bounced around hitting each other. Well, the work he did used flat surfaces, so it was a dodecahedron, and they bounced on flat surfaces, which was completely different from all the other work I had done on molecular dynamics. All the other ones always followed the same pattern. The other interesting thing after this all happened is, looking on the internet, I found the one paper there that was in German that has my name on it with a picture of us. There's the one in Japanese, which even more amused me, is it has from the symposium. What Japanese are interested in seeing a picture of Berni and me in recent picture. Kind of amuses me that it's there. And the work that I did with Dave, it's actually in a Greek translation, somewhere that people are interested in it. And it's just talking about our work. It isn't necessarily translating a paper. It may be telling about my work with Dave. Dave did not have a clearance to work at the lab. He was a postdoc working in the area. I think he was at Cal. And he was working on this issue with Berni about combining all the things that Berni had done on molecular dynamics and making it a general paper that was very useful in the field. And he describes it as talking to me on the telephone, telling me what needed to be done, and giving me something. I would write it up and program it, put it on the machine to run overnight, call him the next day and say, this is what happened. He'd adjust his work and tell me to try something else, and this went on. And he was able to get many, many hours of work on the computers in Livermore just by this process. It's also interesting that when I stopped working for Berni was when they forgot about classical physics and were now going on to quantum mechanics and all the complicated ones, which I did not have any background in at all. So I was kind of complete. My work with him had been completed. They hired Dave in my place, and I think most of the workers after that had their PhDs in physics in that field. But I had happily done my part. And now the question comes is, how did I get to Livermore? I grew up in a very small, rural, little town, little village really, in Minnesota, about 90 miles from Fargo in the central part of Minnesota to the west, and went to the rural school there. My father had originally come from Finland as an immigrant when he was 12 years old. My mother was the daughter of Finnish immigrants who had come to Minnesota, and Dad had lost his farm in the '29 crash. The story is that they brought a calf to the bank the day before, and the next day all the money was gone. They lost what profit they had for the year. But when I was about 5 years old, they were able to buy 5 acres of land near this little town, and then rent the land next door to live on a small farm. We grew our own vegetables, we had cows. It was pretty primitive, I guess. No running water, no electricity. So I grew up very simply, but I had a very happy childhood, and I loved school. School was really important to me, and I think I'd go to school sick sometimes just because I wanted to admit to my mother I didn't feel good. And that continued even to high school. The only time I ever stayed home sick was when I had the mumps, and I couldn't hide that. So in high school, I took every class they offered except biology. I took all the math courses, all the stenography courses, all the thing. And I graduated as valedictorian, so I was a good student. My role model was my science teacher, who was a woman. She taught both math and chemistry and physics. Most of my friends going into college, very few people went to college back in the early 50s. I graduated in 50, I think. They all went the 2-year course to be a teacher, elementary school teacher, and after 2 years you could teach in Minnesota schools. The interesting thing was that Minnesota at the time offered a scholarship to the highest boy and the highest girl in every graduating class in Minnesota. So I was awarded a one-year scholarship to go to the University of Minnesota. I chose the branch, Duluth Teachers State College had just changed over to being a branch of the university, so I went to the university in Duluth, Minnesota. I went to get a degree in, to teach math and science in local schools. However, math was my love, and I took every math course they offered, so I could have graduated with a BS in math with a minor in chemistry, but what I did was got a major with a bachelor's degree in education with chemistry, and math was my major and physics is my minor. So I did have a teaching degree in Minnesota, and I graduated cum laude there. I had, my advisor in college was a woman, so the math advisor, and I had a teacher who was a woman who taught chemistry, although most of my other teachers were men in the science and math departments. So nobody ever made any issue of the fact that I was a girl majoring in the sciences. They treated me, I was very often the only girl in the classes, but even the other students treated me on an equal basis as them. I never ever felt that I didn't belong as a math, science type of person. But when I graduated, I decided that I wasn't going to take a teaching job right away. My sister was living in Berkeley, and she really needed me there. She was expecting her second baby. So I took, as soon as I graduated, I didn't even go home. I got on the Greyhound bus and rode to California. So I came here right on the same summer that I graduated in 1954. So that's how I ended up in California, at least. I don't know what my next picture is. I look. Oh, okay. When I got to California, the first jobs I took while I was looking for other jobs was as a statistical typist. An interesting fact, I found that when I was in high school, I was typing 60 words per minute. I had not typed other than maybe some college papers on a typewriter, but when I took the test for the job, I was doing over 100 words per minute, which to me is almost phenomenal, that you don't have to use a typewriter and you can still increase your speed. I took a job as a chemist for Clorox Chemical Company, and had no supervision at all. My boss did not know anything about what I was doing. I was supposed to find a method of how to automatically complete the Clorox chemical process to stop it without testing, that I could tell when the process was complete just by the simple test, not having somebody take a piece of a cup of Clorox off and see is it complete yet, and then try. And I didn't know what I was doing. My boss did not know what I was doing, and I hated the job. I literally on Friday nights, I could not imagine going to work on Monday morning, but 2 days at home, I forgot and went back. And so when I saw this ad in the Oakland Tribune in February 20th, 1955, no, 56, no, 55, I started in 55, and saw that the ad was there asking for graduates in mathematics at the University of California Radiation Laboratory in Livermore, California. I jumped at the chance, but I didn't know where Livermore was. I didn't have a car. Fortunately, my apartment partner had one, and she was a graduate student at Cal, and she said she'd take me there at the end of the week when she was all through classes. So a late Friday afternoon, we drove to Livermore, which was a little town. I remember having 4,000 people in it. There were no freeways there. It was all highway. You drove through Oakland, you drove through Hayward, you drove on this 3-lane road over the hills to get to Livermore. And it was, I guess, a typical little town in California. Not much to see. This is taken from P Street looking east towards Livermore Avenue, that sort of thing. I had another slide that was really harder to see where it kind of showed the limits of the town, but I eliminated it. And then situated out in the countryside was the Livermore Laboratory, University of California Radiation Laboratory, where this ad did say to go to apply for the job. It was a late Friday afternoon. Most of the people had gone home. They had a big computation department, wasn't there, but his the next under him, Dr. Von Holt, came to interview me, and they did offer me the job. So I was able to leave the my temporary, when they hired me at the Clorox, they told me it was a probationary 3-month period, and I figured I could end the probationary period, even though my boss had gone to the head of the company and said, can't we offer her more than Livermore offers her? But they didn't think it was necessary. So I was so pleased to come somewhere where I could do some math, and to be working on computers sounded exciting. So as people introduced me as, that's too far. No. Here, this is the very first computer that I worked on, the Univac. However, in order to get there, I had to be in the cooler. I think I was there 6 weeks. The ad said that they'd offer a period of training, which was sitting in a hot, unconditioned room, chatting with 25 other hirees who were all kind of vets who'd gone to the GI Bill. They'd been in the Army and were offered college education, and some of them, I guess, had majored in math. But I soon found that the people they hired were not necessarily mathematicians. They were people who had any kind of a scientific background. Finally, we one by one, we get our clearances and we go over to there, and they disappear. None of us knew what a computer was. Nobody showed us a computer. The few times they came to teach us something didn't make sense because we didn't know what a computer was. We couldn't tell whether they were talking about a computer or the program. But it was fun. There were 25 men, I guess, and me. They were all older. I was the youngest. I was probably 22, 23, but I looked 15 or 16. It was very sort of thing. So, and I have to say that once I got to work, they all went somewhere else and worked on the other machines, so that I did not see them after that much. Anyway, I finally went, and they offered me a job to be, it's hard to a human computer, I guess is the word that they describe when they talk about the Hidden Figures, the gals who work in Hidden Figures, and the coding, there's another book about the coders. I can't remember what the name is, we read it for book club, but who sat at computers all day with desk computers, adding up these thousands and thousands and thousands numbers all day to solve the equations in order to do for the ones who worked as for jet propulsion, and for NASA were doing it for going up into outer space. But these people were doing it to check the computers that they had down in the molecular thing. And it was all day sitting at a computer, at a desk calculator, trying to add up all these things that the computers were. And to me, it was no more than asking me to go back to my chemical job, where I was not interested in what I was doing. There were several reasons. Partly I had the chemical job where I couldn't imagine sitting at a desk or doing things that I didn't like doing. The other one, when I was in college, when we took numerical analysis, which was that method of solving equations, the teacher said, "You are here to have fun. I don't want any of you ever to use it. It's just a tedious job if you get a job in it, not knowing that computers are coming out. I'm going to use that field completely." So I was just completely, and I went to the head of the department who had brought me there and said, "I didn't come here to do that I'll go back to teaching rather than work on that job." And he said, "But that's a woman's job. Women enjoy it." Well, it wasn't me. But because I was a woman, I was chosen to do that. There were 3 women in the department who were doing it already, but they wanted a 4th one. And unfortunately, or fortunately, I don't know, the head of the department married one of the workers in that, who was and I don't know if that prejudiced him against me or not, but I will say that the person that they took from me to work in that job to replace what I was supposed to do was in a wheelchair, one of the handicapped people. So it was not a job they were going to offer any of the men that who were strong and sort of thing. It was and I will say that by my refusing it, they did not offer it to any other women who later were employed, and as soon as the head of the group married, the group disappeared. Others moved into working on programming. So, it did start me off on the wrong foot in computation. And I think that was part of the beginning of my being, well, in the bottom 10%, I won't say 1%, 10%. And they assigned me to the Univac, which was the oldest machine that they had at the time. It was the first one. And the first time I went there, I was fascinated. I was awed. I couldn't imagine anything that could add so much faster than me. It just overwhelmed me. I have never been, no other computer has ever impressed me as much as I was impressed by the Univac back in 1955. We get no home computers, and Cora keeps telling me that it's so much faster than the one you have, you better get it. And I couldn't care less. It's faster than the Univac. Well, what's a lot? The Univac is way too fast. The tapes were heavy steel tapes. The input and output was all by a standard typewriter. We switched in the console, we had to do the switching, we toggle screens back and forth to do whatever we wanted to do to start up. We kept our programs on the tape and our data on the tapes. It was a fun thing. Where did I put my little thing? And this kind of describes the casualness of what programming was then. I will say that I did mean to say that I was never given any instruction on the Univac. I was given the list of personal instruction. I was given a piece of paper that had all the instructions that the machine took, and a paper I was supposed to figure out. And my physicist who gave me a program, who described the program that he once solved with the equations. We were in offices that had windows, and one of the fellows who worked on the Univac stopped by and said, "You look so confused, do you need any help?" And I said, "Yes, I just can't figure out how I'm supposed to do this." And so he's probably sat down for an hour, half an hour, to get, maybe even longer, who knows, I can't remember, to explain to me, this is how it works. Well, you make the instructions and tell the computer what to do. And that was my tutoring for the computer. But he became a good friend, and he really enjoyed his work, and I wanted to have a job that I enjoyed, and I caught on this is fun, working on computers is fun, and I kept that attitude all the years I worked on computers. I couldn't imagine having a job that could be that fun. It was a very casual atmosphere. This is the next year. Pardon me, I'm going to take a drink. When the computer was 3 years old, the next April, I think it was, the group got together to celebrate the machine's birthday. I like this picture partly because it tells how informal kind of we were, but we all dressed up to go to work in those days. Men wore ties, suits, women wore stockings, dress-up dresses. I wore dresses all 40 years that I worked, to work every day, although at the end, other women were wearing slacks and tops and more casual work, but I kept wearing dresses and hose the whole while I worked. And now I very seldom wear them. That's one reason I put on the dress today, was it reminded me of the years I worked. I'm in the picture. I don't know if Corey can find me there, peeking out through right there. But how informal we were. Work conditions were very informal because all the programmers were put together in one group. We had to go to the computer and work, and we'd probably sign up for 15-minute intervals, once in the morning, once in the afternoon, if we needed the time on the computers. Our physicist who came to us probably came to us once a day, or as when I did start working with Berni, he only showed up at the lab 2 days a week, so those were the only days that I would see him until I moved to Berkeley, and I would ride back and forth with him, and then I'd only see him on the way to work and the way back. We'd talk our problems or what needed to be solved or what we had doing while commuting, and he did everything else he was doing with other people during the days. So let's see, let's get going again. In addition to the Univac, they had IBM machines. The first one came, I don't have the 701 there, there, but the 704 came the same year I started, and all the rest of the people who were in the cooler with me were assigned to the 704. So because that's why they were hiring, they got an additional computer. And one thing that was I really enjoyed at the lab was the fact that they were always getting newer and newer computers. I don't think anybody else probably had the experience at other places that when they got a computer, they took it and they used it and used it and used it, and were familiar with that computer, and then would get something else. But the lab, because of the weapons project and the years following, there was Sputnik that the Russians went up in space before the Americans did, so we had to put all our effort into doing more and more science work, and so the scientific atmosphere community got bigger and bigger, and they were more. It was more rewarding. More and more people were interested in going into the field. I didn't work for Berni right away. I did start working for him on the Univac, mostly because my partner, office partner, was working for him. But because he came in so seldom, I'd usually be there when she wasn't, and she wasn't, and so he'd just chat with me, and I started working with him. And when she left, within 1 or 2 years, I just naturally took over, and Berni got permission that I could be assigned to him all the time. And so when I did go on the 704 and 709 later, and with the IBM machines, we got the punch cards. You mentioned the punch cards. I went to AAUW. I had a group of us signed up to go to the History Museum, Computer History Museum last November. And while I was there, I didn't have any of these saved, but when I was there, I did ask if I could take some of them just to have at home. I think I knew I was going to talk already, and I thought they'd be good to have. That's right, I was giving a talk to the AAUW people, and I wanted to use it there. They have a lot. It's an interesting place to go if you like computers. I think they had the console of the Univac there. It's hard for me to quite remember because my camera stopped working and my phone stopped working. I couldn't take any pictures, but they have a lot of things, and most of the people I talked to did have lots of experiences with computers, but it sounded more like they were really one computer they'd spend a lot of time with. No one seemed to have the same experience of varied computers. What I thought was interesting, I didn't see it while I was there, but when I was on the internet looking for my name, which I find kind of fascinating, it said that my name appeared on one of the flowchart templates, which it described was on there, and it would have been at the museum we were at, but I didn't know to look for it. But I thought some ways when my name went on, even though I had completely kept away from computers for a long time. And I really was really surprised how much how much there was on the internet with my name attached to it that I never knew about. Let's see. This was the next thing. It certainly was my favorite computer. The lab had their own computer built to their specifications. It was the newest and supposedly the best one to do. Best they could get at the time. There was actually gold in the gold wires in part of the thing, just to make everything long-lasting, I guess, very, it was a decimal machine, and I didn't, I haven't said anything about, but the IBM machines and all the computers after that were octal, were binary 1-1, and then we as computer programmers treated them as octal machines where the numbers go from 1 to 8 instead of 1 to 10, and we learned just to look at memory dumps and all these things while we were working with the computers, which was hands-on at that time. We actually would go to the consoles and work, and we just got really good at using octal number system. But it was comfortable to work on a machine that was a decimal machine, numeric. And so this is one of my favorite machines there. There's a picture of me. We did work at the console ourselves. We signed up for debug periods and we'd go there and we'd work. So I found it very, very fun time to work on a machine. And they kept this machine long after it's, well, it would be considered old and slow, so that it became a unclassified machine for years after it was, and I was connected to it. And the one thing about, when we were on the computers, we used the tapes. We have these pictures of the molecules. This first one is how it looks when a solid just moves in a certain state, but a liquid moves all over. And we studied the process of melting, where it starts out as a solid and then slowly it melts and melts, and eventually the whole thing is liquid. And then from the a fun thing that I did with the pictures they took, there was a Polaroid camera on the Lark, and I think I made one of the first movies, computer-generated movies, where I had to put in every dot, every pixel that showed up on the picture to watch the movement of the particles as they took space. This shows the next series of computers I worked on, the CDCs, the 6600, 7600, and after that, the method we worked is different. The lab started an octopus system, they started a time-sharing system, all of which changed our environment. We could work from our offices. We get teletypes in there and we type there. When we got personal computers, we used them instead. Time sharing meant that lots of people could be working on the computer at the same time. Whenever the high priorities were busy, they got the machine. And the molecular dynamic program step was listed at a priority of 0.03. So that if nothing else was running, I would run. And so when other programs crashed, I was there to take over the time. When it got so that even when somebody was dividing and there was extra time in there, my program would go in there and use that extra time and then quickly get out again when the other one would. And so,
you're jumping backwards.
So this is the CDCs. Huh? Oh, yeah, okay. So the octopus system was the business of getting teletypes in our office. Time sharing was that there were many things running on the computers. And finally, this is the list of all the computers I worked on at the lab. I had 30 at Livermore and 2 in Berkeley. Berni was able to ask them when they got new computers whether I could come over there and use their empty time too. And so Berni had a reputation of being the largest user of computer time at the lab during this period of time. After that, did I miss one?
No.
This is the sequence. I started on the Univac back in 1955. My last computer I worked on was the Cray 1, which was, I retired at the end of 1994. I never did Berni's problem on the Cray. It was, each computer they got was much, much faster than the one before. By the Cray, they were so fast, they didn't care if there was idle time or not. They just let everybody run. Actually, they discouraged being clever, which was one of the reasons I could get so much time, was squeezing every machine cycle time to use up. And now it was more important to have a clear program that anybody could look at and read, whether it was fast or slow. It did the work, and I kind of lost interest at that point. When we were at the computer lab, they had a Cray there, a Cray 1 there. I think it was the one from the lab, but I had never gone to it. Or if I had, it was just to go and see what it looked like. All the other computers, I had actually gone in and hung tapes and gotten output sort of thing. That one I never saw, so I never felt any personal relation to it. So even though the other people in the group thought it was really great that we saw one of the machines I worked at, it didn't do all that much for me. And then the labs keeps getting faster and faster and faster computers. The molecular dynamic program now, when I did things like 500 particles at a time, I did a movie, my movie that I did, or no, the pictures that we did were between 500 or 1,000 particles. That limited in size. The new ones now do billions of collisions, movies that they showed me to look at, and I have looked on it. And they have specific materials. They can name the materials in the movies. This is tungsten, this is something else. So it's advanced really great. But I stopped when they got into the higher physics working for Berni, and most of the work I did after that, I worked with the weather program, and for a long time I just took jobs that nobody had any money for. It's called a burden account. I was on the burden account for 3 years, but I had a variety of assignments, and people took me there, and then finally two of the groups could use half people, so I was a half people for 2 groups, and then one of them finally could get a whole one person to work for him, and then I went to the weather, climate, what is it called, to work the last few years of my career there. So I went from that laboratory to, this is what it looks like in this century, or this decade, I should say. And if my name now were in Wikipedia, it could say this, which is exactly what it said before, except leave out, she's largely forgotten. I don't feel forgotten anymore. That's it. Question? Yes.
That was a wonderful tour of the evolution of hardware from the 50s on through the Cray. I'm curious about the software. I recall you saying that at the beginning of your career, you just had a list of machine instructions, and you write down the machine instructions. I'm curious, did you get any Fortran?
Can you come closer to even give you? I'm having a hard time
So he's asking you, could you describe the software evolution? For example, Fortran, at what point did you use Fortran? Go to the microphone.
Okay, I actually had it in my notes, but it's somehow I forget things and I didn't have that marked out. At the very beginning, we did machine language. We actually did everything: add, subtract, divide, compare, during the IBM period, when we first got the 704, 709, in that period, one of the fellows from the lab went back to IBM and worked with the original Fortran group to establish Fortran. He brought that to the lab, and for many years, the lab just did their own Fortran. It was a really exciting period because at first they had to do the Fortran in machine language before they could let us use it as a language to code by. The big breakthrough was when Fortran could Fortran, for instance, and then it was easier to go from one computer to another. And we used Fortran for years and years. In the 1960s, we started getting people who were majoring in computer science at the universities and coming back with their own versions, and most of it was Fort. We were still using Fortran for many years. We went through several trials, but the lab stuck with Fortran for years until Unix came, but I never worked with Unix. I have to say, I think, what other languages are there?
C++. You did that.
I never worked with C++. I think I went from Fortran to, I can't remember anymore. But there were parts of the lab that worked with the different languages. Actually, it's hard for me to remember. There was another language in there that thing, but we stuck pretty much to those languages. I really can't think of any other. So we really went from a very primitive Fortran to a very sophisticated one. Most of my career, I think I was still using Fortran all the long time I worked with Berni, which was through the early 80s, and then there might have been other languages since. But most of the people by that time had their education at the universities. They weren't depending on self. We taught ourselves all these things. When a new language came out, we'd have lessons in them, but we wouldn't necessarily use them to program. Does that answer?
Yeah, thank you. I might add that we overlapped a little at the lab, although maybe we didn't meet, but I'm in the weather climate group, and most of the world's weather climate prediction models still use Fortran.
So when I worked with them, it probably was still Fortran.
Yeah.
Yeah. Yeah, it was, that period was interesting in that I worked with the scientist I worked with was studying the ozone layer up in the sky and things like that. And he couldn't publish any of his results because it was against the U.S. policy. They didn't believe in climate change, and all of this was part of the climate change background. And so he finally left the lab in order to be able to publish his work. Yeah, one of the codes I worked on was an ozone layer, studying the CO2 coming down from the sky, sort of thing. I can't really think of anything else. So, any other questions?
Thank